3.2 Rolle's theorem and the mean value theorem. So let me go through Rolle's theorem first. Rolle's theorem states if f of x is continuous on AB and differentiable on AB, which means the derivative exists everywhere, which means there's no sharp turns, PODs, or gaps, jumps, vertical asymptotes, all that kind of stuff. You can't have anything in any of those. And f of a is equal to f of b, then there is at least one number c in AB such that f prime of c is equal to 0. Basically, all that means is if a and b are the same, that's this, means they have the same y value, okay, here. So the slope, if you draw a line between them, the slope there is 0, which means f prime is equal to 0. All right, actually, I'll say the slope is equal to 0. Slope is equal to 0. Then because we have to go from here over to here and we're continuous, we can't lift our pen off the paper, there's got to be a point where we turn around. We call that point C. That is the max, or it could be a min. And the derivative at that point has to equal 0. And that just means that the slope of that line and the slope of that line are the same. That's all the mean or Rolle's theorem says. It's kind of intuitive when you look at the graph. You could have another graph where as long as you finish at the same heights on A and B, so if you start here, you go up, you can even dip below it, and you come up, and you finish at the same height. Let's make sure it's the same height. As long as A and B are the same, then you will have at least one. It says at least one, but there can be more. In the case that I have right here, there's one right there. That's going to have f prime of c is equal to 0. One right here, call that d. F prime of d would equal 0. And if you call this one e, f prime of e will equal 0. You will have a max or a min somewhere because the graph has to turn to get back to its original height, the two endpoints. Now, if you take that graph, that theorem, this graph right here, and you tilt it, you get basically the mean value theorem, which says if f of x is continuous and differentiable, all right, again, no sharp turns, no PODs, nothing like that, then there exists a number c such that f prime of c is equal to f of b minus f of a over b minus a. It's the exact same thing. All it's saying is that a and b, the heights of them, don't have to be the same like it was in Rolle's theorem up here. So if you draw a line between a and b and take the slope of it, slope between 2 points, if you remember math 10, it's y2 minus y1 over x2 minus x1. We will just write that as your y2 value is going to be, that is y2, if you think of it that way. It's your value of the function at b. y1 is f of a. So that's why it looks like this. And then x2, x1 is really just your a and your b. That's why it looks like that. We're saying that the slope of that line will equal the slope at some point c on the graph will equal that slope. And the slope of that line is the derivative of c. So that's where you get f prime of some point c. The slope of that, or the derivative of that point, which is the slope, will equal the slope of the secant line here. That's it. That's all the mean value theorem says. Now, that is really important, especially in higher level maths when you're going to be doing proofs and things like that. But there's a couple of examples where we can show how to use it. I'm not going to go through the car example, the speeding car one that he did in class. I think he's going to post it online for you guys. If you want me to do that, ask me tomorrow or some point in the future, and I can go through that. But I'm going to show you a couple of other questions you could do. So here's the question. Can MVT is the mean value theorem be applied, and if so, determine the point C such that it satisfies MVT. Determine the point C such that it satisfies the MVT. Okay, so two examples. First one, here's our function. X plus 1 over x on the interval -1, 2. All right, so what you do is you look at your function. The first thing you have to ask, is it continuous and differentiable everywhere on that interval that we're talking about, okay? If it is not, I don't know why that's not working. There we go. Okay, it has to be continuous and differentiable on AB. So we look at this function. Is this function continuous? No, it is not. All right, it has a discontinuity at x is equal to 0. So MVT doesn't even apply to it. So you just go, and 0 is in our interval. Okay, so the mean value theorem is not applicable because f of x is not continuous at x equals 0, which is on our domain. All right, our domain is from -1 to 2. 0 fits in there. Because the function is not continuous, then we cannot apply the mean value theorem. So that's it. That part of the question, you're done with that question. So second question. Okay. Use the MVT for x4 minus 8x on the interval 0 and 2. So first thing, is the function continuous? Yes. Is it differentiable everywhere? It is, because remember, so let's say continuous, because there's no variable in the denominator, so that works. Is it differentiable on 0, 2? So remember, when did we have when was the function not differentiable? If it had asymptotes, well, you can see it doesn't have any asymptotes because we don't have any variables in the denominator. So that excludes asymptotes and PODs and all that kind of stuff. But there was one time when we did have a function, and that is when you have fractional exponents, right? Because if you took the derivative of that, you would get 1/3 x to the -2/3, which actually means 1/3x to the 2/3. So it's not differentiable at x is equal to 0 because the derivative doesn't exist. But because we have whole numbers here, we don't have to worry about that. And so that's all irrelevant. All right, so it is differentiable. Check. So then we use the formula. It might go away. Okay, so the formula is f prime of c is equal to f of b minus f of a over b minus a. That's the mean value theorem. Go back up. There it is, right there. Okay, so you write that. We're trying to figure out what c is. We go, okay, well, f prime. Let's figure out f prime. So f prime is 4x cubed minus 8. I'm trying to figure out f prime of c, so I just put c in for x. So I get 4c cubed minus 8 is equal to f of b, f of a. That's a, that's b. They're your endpoints. F of b is put 2 in to the function because it's f, right? Not f primed. So I get 2 to the 4th minus 8 times 2 minus f of a. So I put 0 in for all that. Now, obviously, it's going to be 0, but I'm going to put in just for good practice. And when you're subtracting, please put everything in brackets over b minus a, 2 minus 0. Now you just solve for c. So this all goes away because it's zeros. I have 4c cubed minus 8 is equal to 2 to the 4 is 16 minus 8 times 2. 16 over 2. What's 16 minus 16? 0. 0 over 2 is just 0. So I'm going to move the 8 over. It was 8. C cubed divided by 4 is equal to 2. Therefore, C is equal to the cube root of 2. And that is it. That's all you do. First of all, let's recap. When you have the mean value theorem and they ask you to find C, you check to see if the function is continuous. If it's not continuous, you throw it out, you're done, it doesn't even apply. You also have to check to see if it's differentiable. The only time it won't be differentiable on your interval is if you have those fractional exponents, remember, and fractional exponents that are less than 1. So x to the 2/3, x to the 3/4. But if you have x to the 4/3, that is fine, because that would be to the 1/3, right? That would be the derivative of that. And so this is still a positive exponent. So just watch that. As long as the fractional exponent is less than 1, when you subtract 1, you're going to generate a negative number, flips to the bottom, and then you have a non-differentiable function at a certain point. So it has to be continuous and differentiable on your interval. If it is, you write out mean value theorem. F prime of C is equal to f of B minus f of A over B minus A. Your A's and B's are your domain. F prime of C, take the derivative of your function, just here, throw in C, and then you just algebra it and solve for C. Cube root of 2. All right, your practice questions, 174, numbers, 31, 33, 37, 39, 41, 43, and 45. Enjoy, peoples. Bye-bye.